Assalamu alaikum, student. Are you listening me?
Walaikum assalam, sir. Yes.
Okay, thank you. We welcome to Dr. Arooj Adeel and all other participants from the Department of Mathematics, University of Education, Lahore, Multan campus in the seminar. We are grateful to our VC Saab and campus principal for organizing and conducting the online seminars. We are extremely thankful to the Dr. Arooj Adeel for joining us in the seminar as an invited speaker. Dr. Arooj Adeel is an assistant professor of mathematics at the University of Education, Bank Road campus, Lahore. Her research area is fuzzy set theory and is the batch fellow of Dr. Anam Lukman. Now I would like to cordially invite Dr. Arooj Adeel for the talk. Dr. Arooj Adeel, are you ready for a talk?
Thank you, sir, for such a nice introduction. Yes, I am
Okay,
ready.
madam.
I will
Thank
share
you,
my
madam.
screen. Kindly tell me कि आपके साथ screen जो है वो share हो रही है या नहीं.
Okay, madam. You can share your slides.
I have shared my screen. Please confirm me it is showing to you or not.
Madam, yes, okay. These are okay, I think. For me, these are okay.
Okay, should I start or not?
Yes, you can start.
Okay, thank you, sir. I am Dr. Arooj Adeel, Assistant Professor from Department of Mathematics, University of Education, Bank Road Campus, Lahore. In the name of Allah, who is the most beneficent and the merciful. Assalamu alaikum to everyone. Today I am going to present on the topic M-polar Hesitant Fuzzy Topsis Approach. The layout of this presentation consists of introduction, M-polar Hesitant Fuzzy sets, basic operations, M-polar Hesitant Fuzzy Topsis approach, and at the end, its conclusion. Introduction. When people compose a decision, mostly they are hesitant and doubtful for one thing or another, which causes difficulty to approach a final agreement. There does not exist any difficulty to establish a common membership degree because we only have to deal with one possible value in the case of fuzzy sets or a margin of error in the case of interval valued hesitant fuzzy sets. But in most of the cases, we have experienced a set of several possible values. In such cases, to attain the more equitable decision result, a decision assembly contains a lot of decision makers or experts authorized to present the preference information about a set of possible alternatives. Usually, the decision assembly is not very sure about a value, but has the hesitancy between several possible values. Then it estimates the degrees that an alternative should satisfy an attribute. To deal with the hesitant situation, which were not well managed by the previous tools, a new extension of fuzzy sets, so-called the hesitant fuzzy sets, has been introduced by Tora in 2009 in an international conference on fuzzy systems. The Hesitant fuzzy set permits the membership degree of an element to be a set of several possible values between 0 and 1. This situation is very usual in decision making when an expert might consider different degrees of membership, maybe T2, the degrees of membership 0.67, 0.82, 0.87, 0.74 according to his choice for the alternative set. It is also a useful tool to express a realistic situation where different persons are attached in analyzing the process of decision making. Due to the unpredictability of real-world problems and the limitations of the human observations, it is very challenging to apply only a particular or specific uncertainty method to deal with complex problems. that one can approach to more impressive and effective models through handling decision-making problems by relating or associating the advantages of several other distinct theories of uncertainty. Hesitant fuzzy sets are considered more efficient to deal with the uncertain conditions because by combining such a theory with several other useful theories or models, novel hybrid models can be developed for decision-making problems, and the aim of this research is to construct the novel hybrid model based on the Hesitant fuzzy set. Because the use of Hesitant fuzzy computations makes the decision-maker assessment more feasible and significant in decision making, and the proposed model is basically named as the M-polar Hesitant fuzzy set. This model is obtained by the hybridization of the fuzzy set with an M-polar fuzzy set, which is more flexible and expressive for modeling and processing of vague information under the hesitant. This model basically provides us information to tackle the multipolar information with hesitancy. Next, we move towards the formal definition of the Hesitant fuzzy set. In Hesitant fuzzy set, O is considered as the reference set, where the Hesitant fuzzy set on O is a function defined in terms that, when applied to O, returns a subset in the closed interval 0, 1. And several researchers named it by alphabetically, like here it is given in the form of J. Here O is the reference set element, and Hj is the different values in closed interval 0, 1, which represent the several points represent the Hesitant fuzzy element. Next is the formal definition of M-polar fuzzy sets. An M-polar fuzzy set on a non-empty set U is the mapping C from U to closed interval 0, 1 for M. Here in this case, we obtain an M tuple of membership values, which is given in the form of Cx. And here in this case, each membership value in a tuple is a mapping from closed interval 0, 1 for M to the closed interval 0, 1. That means each membership value is also obtained from the closed interval 0, 1, which is basically the ith projection mapping. The M-polar Hesitant fuzzy sets have a representative and fundamental role in several fields of science and decision making. The fusion of M-polar fuzzy sets with several other theories of mathematics has become a favorable practice for depicting numerous types of uncertainties under multipolar information. In proposed research, an innovative hybrid model, which is known as M-polar Hesitant fuzzy set, is introduced, and it tackles the multipolar information with hesitancy. Hesitancy incorporates symmetry into the treatment of the data, whereas the M-polar Hesitant fuzzy format allows for differentiated and asymmetric sources of information. M-polar Hesitant fuzzy set was introduced by Chen et al. In 2014, and its first paper is published in the Scientific World Journal. Basically, M-polar Hesitant fuzzy set is the extension of bipolar fuzzy sets. Next is the definition of M-polar Hesitant fuzzy set. Here, in the case of M-polar Hesitant fuzzy set, Z is considered as the reference set, and an M-polar Hesitant fuzzy set on Z is the function Hm that returns a subset of the values in closed interval 0, 1 for M. Like when we apply this mapping on the reference set, we obtain an M tuple of different values in which each membership value is itself a set, which is given here in this form Hm of Z. That you can all see that each membership value is itself a set. This notion shows that Hm is an M tuple of sets having possible membership degrees of each element. Here in this case, if we take M is equal to 1, then the M-polar Hesitant fuzzy element reduces to the Hesitant fuzzy element. Next we move towards the example of M-polar Hesitant Fuzzy set, which is very helpful to understand the concept of the M-polar Hesitant Fuzzy set. Here in this example, we take C as the reference set and their age M of Z1, like their M-polar Hesitant Fuzzy set according to the each element of the reference set is defined over here. There three elements of the M-polar Hesitant Fuzzy elements are given in the form of a 3, like the M is equal to 3 and we get the 3 values for this tuple, and each value of this tuple is itself a set having 2 membership values and 3 membership values. It may be changed according to the decision maker settlement. If we join all these M-polar Hesitant Fuzzy elements or these 3 polar Hesitant Fuzzy elements into a set, we get the 3 polar Hesitant Fuzzy set. Here are some of the special M-polar Hesitant Fuzzy elements which are given in this slide. The first one is the empty set, which is represented by this notation, the full set, complete ignorance, and nonsense set. Next we move toward the sum of the basic operations of the M-polar Hesitant Fuzzy set. The first one is the lower bound. In the lower bound, we take the infimum of the each membership value, which is basically a set of this M tuple. And the next one is the upper bound. In upper bound, we take the supremum of the each element of the, or we can say the each membership value of this M tuple. The next operation is the complement. Complement is just the simple complement like the M-polar Hesitant Fuzzy set or the M-polar Fuzzy set or Hesitant Fuzzy set, just we take the difference from 1 to the membership value. Like in this tuple, we take the difference of each membership value, which is a set, its difference from 1. Next is the union, which is given in this slide. And the next one is the intersection. It is given in this slide that we can find the intersection by taking the highest membership values. After taking the highest pair membership values from this tuple, we take its infimum. Similarly, we can find its union in the case of supremum. Here is the direct sum. In the direct sum, when we take the direct sum of the 2 M-polar Hesitant Fuzzy sets, then we add their membership values, and after that we take their product. When we take their product and we add them, we subtract these values and we got the direct sum. Next is the direct product, which is also calculated here in this slide. Here we just take the product of the M-polar Hesitant Fuzzy elements. Next is the comparison laws of the M-polar Hesitant Fuzzy elements. The first one is the score function, which is basically a standard tool for comparing the Hesitant Fuzzy elements and the generalized concept. The score function is basically the sum of all the membership values. If we take the sum of all the membership values and we divide it the total number of the elements. Here is the sum of the inferior form of the score functions, where when a score is superior and when a score is inferior is given in this condition, and the score is indifferent when 2 scores of the different M-polar Hesitant Fuzzy elements are equal. They will be indifferent. But if there is no difference, or we can say if they are not equal, then both the elements are totally different. There the score function fails to evaluate. When the score function fails to evaluate, we use the deviation degree, which basically use to tie and to tell which one is the superior, that which membership value for which set is superior. Here is the definition of the deviation degree, where we first calculate the score. When we calculate the score, we subtract it from the previous membership value and we take its square. After taking its square, we add all these values and then we divide it to the total number of the elements. After doing all these operations, we take the square root. Then we get the deviation degree of the M polar Hesitant for the elements. Here are some relationships of the deviation degree like the score function. Next is the decision making technique, which is known as the M polar Hesitant Fuzzy Topsis Approach, and this approach is based on the M polar Hesitant Fuzzy sets that deals with the multi-criteria group decision making problems, where we take V as a reference set or the set of objects or the set of alternatives, and the C is considered as the set of criteria which are distinguished by M different characteristics under hesitant situation. This framework of the problem is as follows: that decision makers are subject to evaluate the P different alternatives having Q different criteria, and the convenience valuations of the alternative are determined having M different characteristics under R different membership values due to the hesitancy. The steps of the proposed approach are described in the next slide. That first of all, the degree of each alternative over all the criteria are given by the M polar Hesitant Fuzzy elements, which are given in this form, and they classify the several other characteristics of the each criteria. Here next is the tabular representation of the M polar Hesitant Fuzzy decision matrix, in which C1 to Z3 show the number of alternatives and C1 to C2 shows the number of criteria, where these values basically are the M tuples of the hesitant fuzzy values. And how these values are calculated are given in this next slide. That each tuple which is defined is basically the set different elements of the set, or we can say that each membership value of this tuple is the set. The number of the M polar Hesitant Fuzzy elements is basically not comparable in all the M polar Hesitant Fuzzy sets. So in order to increase their efficiency, the largest and the smallest membership values are prolonged until the length of all the M polar Hesitant Fuzzy elements become equal. As decision makers want to choose the best alternative in an optimistic or pessimistic spirit, for this reason, the information fusion shows an optimistic or the pessimistic response and improves the M polar Hesitant Fuzzy data by adding its maximal or minimal values. In the next step, we are required about the weights, which are on the behalf of the decision makers. We choose the weights according to the criteria. The number of criteria are equal to the number of weights. And here we choose the weights which sum is equal to 1. That we can say we should have to choose the normalized weights. Where are the different methods to normalize the weight? First or the most important method is the Shannon method. In the next step, the weighted M polar Hesitant Fuzzy decision matrix is calculated. In this matrix or in this table, we multiply the weights with the criteria and we get a new generic weighted M polar Hesitant Fuzzy decision matrix, which is calculated in table 2, and its each membership value have the formulation as given in this slide. That we can see that weight is multiplied with the membership values in M tuple. In each set, the weight is multiplied. In the fourth step of our proposed technique, M polar Hesitant Fuzzy positive ideal solutions and M polar Hesitant Fuzzy negative ideal solution of the alternatives are calculated, which are given in the equation 1 and 2. Where in M polar Hesitant Fuzzy positive ideal solution, these positive values are basically have the formulation given in this slide, that the maximum value of our set, the maximum value of the sets given in the M tuple, we call the M polar Hesitant Fuzzy positive ideal solution. And the next is to find the M polar Hesitant Fuzzy negative ideal solution, where these negative values have the formulation given in this slide, which is basically the minimum of these values. In the next steps, we have to find the M polar Hessian fuzzy region distance, which is basically the distance of the alternative from the M polar Hessian fuzzy positive ideal solution and negative ideal solution. And these solutions are calculated by using the formulas given in 3 and 4. And in the last step of this method, we calculate the M polar Hessian fuzzy closeness coefficient, which is basically the ratio of the M polar Hessian fuzzy ends of ideal solution to the sum of the M polar Hessian fuzzy positive ideal solution and negative ideal solution. After this step, we will be able to find the ranking of the alternative, and we will also be able to find the best alternative. And next is the example in which I have applied this proposed method, and its name is the selection of a perfect brand name. And the proposed CN model is applied in the strategic marketing, namely the choice of a perfect brand name. This is one of the fundamental decisions when launching a new product into the market. A perfect brand name is not something that looks fine on a business card or a web banner, or is cool to say, or if somebody likes it. It is perfect when it conveys the right feelings to the customer from whom the demand for good brand name emanates. A good name can be the most prized property of a company. There exist many theories and have been many studies about what makes a good brand name and common principle, which makes a brand name simpler for the owner to use and easier for the customer to remember, that have been established. Ideally, one must take advantage of a fusion of information that derives from multipolar advice under the Hessian direction. An M-polar Hessian set handles all the characteristics and tools to select a brand name in terms of M different numeric values under Hessian situation, and due to the guidelines of different decision makers or experts. For this purpose, we choose a set of 5 different brand names, which is given in this form, and C with a set of 3 different evaluating criteria, which is given in this form. And to finding a good brand name that can be exhausting and thrilling, but there are some criteria such as its articulate core identity, brainstorm, and test, which are further classified. We choose these criteria basically: articulate core identity, brainstorm, and test. But we further classified these criteria into the 4 different other characteristics because we are using the technique of M polar Hessian fuzzy set, and here in this case we choose M is equal to 4 because M is an ordinal number. The first criteria, which is the articulate core identity, is further classified into the vision, mission, value, and direction. Where vision says why your company exists, mission says what your company does, and the value says how you do what you do, and direction says where it goes on. Similarly, the next criteria, brainstorm, classified into the 4 different characteristics, which are the founder, description, magic spell, fabricated, where founder means a name based on the real or fictional person, and similarly all these descriptions of the criteria are given in this slide. And our third criteria, which is known as test, is further classified into the 4 different values or 4 different characteristics, which are the sounds good, not confusing, not mispronounced, and related publicity, and their description is given in this slide. That sound good says that it is good to hear, not confusing says that it is not linked with other brand names, and similarly the next 2 characteristics are described. All these characteristics are assessed by a group of 3 decision makers who are responsible for evaluating the brand names. Due to their mutual decisions, each criteria has a specified condition for further classification of described values into 3 Hessian fuzzy values for any given candidate brand name, that decision makers have the authority to choose the further membership values between the closed interval 0 1, and the assigned values are described in the table 3, which is given over here. Table 3 basically describes the 4 polar Hessian fuzzy decision matrix. In this matrix or in this table, the 5 brand names are chosen, which are chosen in the first slides of this example, and 3 criteria: articulate core identity, brainstorm, and test are given. Where each criteria is further classified, their different values, 4 values, which are given in this form, and their membership values are also assigned here in the table 3. Which is the basically first step of our proposed technique. In next step, we find the optimistic 4 polar Hessian fuzzy decision matrix by adding the maximal value, which is given in table 4 and given in this slide here. In the next step, which is to assign the weights to the values. Here the decision maker decides to choose these weights like 0.23, 0.34 and 0.43, and these weights are normalized weights and satisfy the normalized condition because their sum is equal to 1. Next, we find the weighted optimistic 4 polar Hessian fuzzy decision matrix. In this case, we multiply each membership value in the form of set with the weight, and we get a weighted optimistic 4 polar Hessian fuzzy decision matrix, which is calculated in table 5. Our next step is to calculate the 4 polar Hessian fuzzy positive ideal solution, which is calculated according to the formula that is described in the formulation of the M polar Hessian fuzzy Topsis method. In next step, we calculate the 4 polar Hessian fuzzy negative ideal solution. And in the next step, we calculate the 4 polar Hessian fuzzy Euclidean distances of the brand name from 4 polar Hessian fuzzy positive ideal solution and negative ideal solution. Here we get the distances that you can see. These distances are from the 4 polar Hessian fuzzy positive ideal solution, and these distances are calculated from the 4 polar Hessian fuzzy negative ideal solution. Here we get the 5 distances from the positive ideal and 5 distances for the negative ideal solution. Next, we move towards the last step, which is the relative closeness coefficient. And here we calculate the relative 4 polar Hessian fuzzy closeness coefficient of the brand name, which are the 5 values, 5 final values. From these 5 final values, we will be able to rank the brand names and to find the best brand name. Here we can see their ranking, that 3 and 1 is the best brand name for selection, and their ranking is also given in this slide. Now it's time to conclude this presentation. That Hesitant Fuzzy set theory is an impressive tool to express the vagueness and ambiguity derived from experts to analyze the characteristics of the object and to determine the membership function for each criteria domain. In real-life problems, hesitant structures are generally preferred as compared to the clear-cut situations. Hesitant Fuzzy set illustrates the conditions that allow the membership of an element to the required set containing various values, which are beneficial to handle the uncertain data in the procedure of multi-attribute decision making. The Hesitant Fuzzy set is combined with other theories such as ampolar fuzzy sets in order to introduce the concept of the novel hybrid model, and the proposed hybrid model and its decision-making method provide more accurate and compatible results to facilitate the management of hesitation, uncertainty, and vagueness motivated by the multi-attribute and multipolar information. Here is some of the references regarding to this presentation. Thank you very much for listening me. For any question, you can ask.
Thank you, madam. You explained each and everything related to the seminar or the topics. It was a detailed seminar related to the topics. Now I will ask to the students to ask any question related to this topic.
For any question, you can feel free to ask.
अस्सलाम वालेकुम मैम।
जी वालेकुम अस्सलाम।
मैम जब हम ये टेबल बनाएंगे अल्टरनेटिव और क्राइटेरिया का, मैम ये नंबर ऑफ क्राइटेरिया और नंबर ऑफ अल्टरनेटिव मुख्तलिफ होंगे या इनके इक्वली साइज होना चाहिए?
नहीं, it can be different according to the choice of decision maker. There is no condition that the decision makers or you can say the alternatives or the criteria must have to be equal. They can be different.
Thanks मैम।
Any other questions from the participants? Okay, madam, I think there is no other questions. Thank you once again for your detailed presentations. Inshallah, we will do our best to invite you again with the new problems.
Thank you, sir. Thank you so much for inviting me
Okay.
in such a beautiful seminar. Thank you so much.
Thank you, madam. I think we should get the call. Thank you.
Should we leave this seminar or not?
Ji, madam.
Should we leave this seminar or not?
Why not, madam? Now we should quitting the call.